Continue with exercise 6D, geometry, question number 20. We have triangle ABC and triangle AMP are two right angle at B and M respectively, such that angle MAP equal angle BAC. So we have to prove those two triangles are similar. The ratio of their side are equal. We have triangle ABC. You see right angle at B. We may draw it that way. ABC right angle at B. ABC. Then what they say, angle MAP equal angle BAC. So that means let's name this one as A, this one as C. So angle BAC equal MAP. So I may extend this one like that. So here MAP. Then angle M is 90 degree. Okay. So here you see we have angle B 90, angle M also 90 degree. Then already given angle BAC equal angle MAP. So we have to prove that those two triangles are similar. So from here only we have angle B equal angle M, each 90 degree already given. Then these two also given equal. So if two angles are equal, that means these two triangles are similar. So if they are similar, we can take the ratio of the side. We have CA hypotenuse by AP, which is also hypotenuse. Then what else we want? CA, we want BC. BC is the perpendicular by MP. Okay, so once the triangle are similar, the ratio of the side of similar triangle are equal. So we prove those. Remember, for similarity, either we need at least two angle or we need sides. Okay, but here it's given angle, so we do. So please write properly. Compare those two triangles. We have these two are equal because each 90 degree. This one already given, and at the same time they are vertically opposite angle. Then that is why, because we have two angles are equal, the triangle are similar by AA similarity. So if the triangle are similar, the ratio of corresponding side will be equal. So that's why if we take base by base equal to hypotenuse by hypotenuse or perpendicular with perpendicular. We will move on next to question number 21. We have a right triangle ABC, then right angle at B here. Then D, it is a point on hypotenuse such that BD is perpendicular to AC. Then we also have DP perpendicular to AB, DQ perpendicular to BC. So we need to prove DQ square equal to DP into QC and DP square equal DQ into AP. Remember here we have right triangle. So we have the right triangle similar theorem. If we have a right triangle like this, then if we draw any line from right angle perpendicular to hypotenuse, then what will happen? These two small triangle, they will be similar to one another. At the same time, it will be similar to this big triangle. That is what we call RHS similarity theorem. Okay, if we draw perpendicular from 90 degree to the hypotenuse, then these two small angle which are made inside the big triangle, they will be similar to one another, at the same time similar to this big one. So here we have to make use of that. Okay, so if we look first from this big triangle, we have ABC, angle B is a right triangle. So then from B, which is 90 degree, we draw BD perpendicular to AC. That is already given. Okay, so that is why we get right triangle ADB, right triangle BDC. They will be similar to one another and also similar to triangle ABC. Okay, so if the triangle are similar, we can take the ratio of the side. Then here we have, again you see, this one is 90 degree. Then you see from 90 degree we draw DP perpendicular to AB. So it means DPB is one right triangle, DPA another right triangle, forming on right triangle ADB. So this one and this one and this one will be similar. So if the triangle are similar, we can take the ratio of the side. Then here again we have angle D, this one, it is 90 degree. Then from here to the hypotenuse we draw perpendicular. So that's why we get triangle DQB. It is a small right triangle. DQC, small right triangle on right triangle BDC. So that is why this small one, they are similar to one another, also similar to right triangle BDC. So since the triangle are similar, we can take the ratio of the side to get this one. Okay, then if we look here carefully, you can see this angle here is 90 degree, this one also 90, this one also 90. So automatically this one also become 90. So when each angle is 90 degree, and also you see because this one it is 90 degree. So we know that when in a quadrilateral, if each angle is 90 degree, then either it will be rectangle or square. So here because the sides are not equal, so we can say that it is rectangle. So if it's rectangle, that means DP will be equal to QB. Opposite side are equal, okay, because it take the shape of rectangle. Then PB will be equal to DQ. So now let us see how to take the ratio. So for the proof, if we see for number 2, we have dp square equal dq into ap. So here we have dp, here we have ap. So let us compare this two triangle first. So here you can clearly see, like I already told, ADP is a right triangle. Then DP perpendicular draw from 90 to hypotenuse. So that is why triangle APD will be similar to triangle PDB will be similar to big triangle ADB by RHS similarity theorem. So that is why we can take the ratio between these two triangle. Okay. Then when we want DQ, we can compare the other side. So there we can write, because we have this line are perpendicular, so by RHS similarity, then we can write those two. Okay, the big triangle is similar to the smaller two. Then from there we can take those DP perpendicular AB also by RHS similarity. Then theorem, we can take this. So if we compare, we can take the ratio of the side. If we draw in short those two, okay, so that you will understand better. DPA and BPD. So if you take DP, you have to take BP, okay, because 90 degree you have to put in properly so that we get the corresponding side. Then PA, then PD. AD we don't want, BD we don't want, so no need to take. Okay, those. Then you cross multiply. PD into PD, it is equal to DP square. Then here we have BP into PA. But if you see here, we don't want, we get BP here, but here we don't want BP, we want DQ. So that is why we have to prove first there is something related between DP and this BP. Okay, DP and we have to prove something related to, we have BP, but the question 1 DQ. So like I already told you here now, because each angle is 90 degree, so this one is a rectangle. So if it is a rectangle, the opposite side are equal. So we can write it that way, okay? Because each angle is 90 degrees, so rectangle, we know opposite side are equal. So that's why DP is equal to BQ and DQ is equal to BP. So now here in place of BP, we can replace with DQ. So it become DP square equal DQ into AP. Okay, which the question 1. Next we'll check for this one. So we will take DQ perpendicular to BC. So by right triangle similarity, we have these two. They will be similar to one another, so we can compare them to take the ratio. So we better draw in such a way that 90 degree are coming on one side. Okay, so we want DQ square, right? So we'll take BQ by DQ equal QD by QC. BD we don't want, DC we don't want, so you can't forget them. Then again here we can cross multiply. DQ into DQ, DQ square, BQ into QC. But what the question 1? DQ square we want, QC we want, but we don't want we get BQ. But the question 1 DP. Then we already see from here we get DP equal BQ, opposite side of rectangle. So there we can replace, instead of BQ we can replace with DP. So then we get what the question 1. So since we get both the condition, the question is complete.